Assalamualaikum warahmatullahi wabarakatuh. My name is Zul Hairi BMMA. So today I would like to present about power conservation law, Ohm's law, KCL and KVL. Power conservation law. Electric power. The electric power gives the rate at which energy is transferred by a circuit. Electric power is measured in watts. This power is consumed when a voltage causes current to flow in circuit. The equation is P equal to V times I. So this is example how do we calculate the power. Consider the below circuit where battery of 6 volt is connected to a 6 ohms load. Ammeter and voltmeters are connected to the circuit to measure the current and voltage practically. But using the Ohm's law, we can find the current and power as follows. From Ohm's law, V equal to IR, we can state as I equal to V divided by R. Then I equal to 6 volt divided by 6 ohms. Then we get 1 ampere. So using P equal to V times I, which is current, P equal to 6 volt times by 1 ampere. So we get power 6 watts. Ohm's law. What is Ohm's law? Ohm's law is the inner core equation used in electrical circuits. It states that the potential difference between 2 points on a circuit equals the product of the current between those points and the total resistance of all electrical devices existing between those 2 points. The greater the voltage, the greater the current. The equation is V equal to I times R. So, who creates Ohm's law? Ohm's law was created by George Simon Ohm. Ohm was born in Erlangen, Germany on 16 March 1789. Attends University of Erlangen-Nuremberg starting in 1805 and later receiving a doctorate. He taught mathematics in local schools before becoming a professor of mathematics at Jesuit College in 1817. Example problem 1, Ohm's law. Find the current I through a resistor of resistance R equal to 2 ohm if the voltage across the resistor is 6 volt. The first step is substitute R in as 2 and V in as 6 in equation Ohm's law V equal to IR. The second step, you will get 6 equal to 2 I, which is current. Once you divide the 6 divided by 2, we are left with the current I equal to 3 ampere. So the answer is 3 ampere. So next is the example problem 2, Ohm's law. In the circuit below, resistor R1 and R2 are in series and have resistance of 5 ohm and 10 ohm respectively. The voltage across resistor R1 is equal to 4 volt. Find the current passing through resistor R2 and the voltage across the same resistor. So we use Ohm's law V equal to IR to find the current I1 passing through R1. So we will get 4 equal to I1 times by 5. Then we solve for I1 equal to 4 divided by 5 is equal to 0.8 ampere. So the current for I1 is 0.8 ampere. The two resistors are in series, and therefore the same current passes through them. Hence, the current I2 through R2 is equal to 0.8 ampere. We now use Ohm's law to find the voltage V2 across resistor R2. So, V2 equal to R2 times I2 equal to 10 times 0.8 equal to 8 volt. So, the voltage 2 is equal to 8 volt. So next, I will explain about Kirchhoff current law KCL and Kirchhoff voltage law KVL. So what is Kirchhoff current law KCL? Kirchhoff current law of KCL states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave. If I1 and I2 is the current flowing in, then we have I1 plus I2 equal to I3 plus I4 plus I5. So the algebraic sum of the currents meeting at a point is 0. Sum of total current equal to 0. What about Kirchhoff voltage law KVL? Kirchhoff voltage law states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drop within the same loop. Starting at any point in the loop, continue in the same direction, noting the direction of all the voltage drops, either positive or negative, and returning back to the same starting point. It is important to maintain the same direction, either clockwise or anti-clockwise, or the final voltage sum will not be equal to 0. We can use Kirchhoff voltage law when analyzing series circuits. So next, we will proceed with the example KCL and KVL. Find the current flowing in the 40 ohm resistor R3. 40 ohm resistor R3. The circuit has 3 branches, 2 nodes A and B, and 2 independent loops 1, 2. By using Kirchhoff's current law KCL, the equations are given as at node A, I1 plus I2 equal to I3, and at node B, I3 equal to I1 plus I2. So, using Kirchhoff's voltage law KVL, the equations are given as loop 1 is given as 10 equal to R1 I1 plus R3 I3 equal to 10 I1 plus 40 I3, and loop 2 is given as 20 equal to R2 I2 plus R3 I3 equal to 20 I2 plus 40 I3, and the loop 3 is given as 10 minus 20 equal to 10 I1 minus 20 I2. As I3 is the sum of I1 plus I2, we can rewrite the equations as equation number 1. 10 equal to 10 I1 plus 40 in bracket I1 plus I2 close bracket equal to 50 I1 plus 40 I2. And equation number 2, 20 equal to 20 I2 plus 40 in bracket I1 plus I2 close bracket equal to 40 I1 plus 60 I2. We now have two simultaneous equations that can be reduced to give us the values of I1 and I2. Substitute substitution of I1 in terms of I2 gives us the value of I1 as negative 0.143 amperes, and substitution of I2 in terms of I1 gives us the value of I2 as positive 0.429 amperes, as I3 equal to I1 plus I2. The current flowing in resistor R3 is given as negative 0.143 plus 0.429, and we get 0.286 amperes. And the voltage across the resistor R3 is given as 0.289 times by 40, and we get the 11.44 volts. So we get the R3 is given is 11.44 volts. The negative sign for I1 means that the direction of current flow initially chosen was wrong, but nevertheless still valid. In fact, the 20 volt battery is charging the 10 volt battery. For the conclusion, we know that the voltage is a measurement of potential between 2 points. For the power conservation law, we know that the power is equal to voltage times with the current, and the unit of power is watts. However, for the Ohm's law, we need to know that the equation is V equal to IR, voltage equal to current times with the resistor. Lastly, for the KCL and KVL, we also know that Kirchhoff's law tells us how the voltage and currents in different branches are related. For the KCL is current in equal to current out, while KVL is voltage in equal to voltage out. Thank you.